Okay, so this question says a rectangular sheet of metal measuring 10 centimeters by 12 centimeters is to be used to construct an open rectangular tray. The tray will be constructed by cutting out 4 equal squares from the corners of the sheet as shown in the diagram. Part A, if the edge of each cutout square is x centimeters, so this is x and that's x, express L and W in terms of x. Okay, well the length, hopefully you can see that it says the tray is 12 centimeters long. The length is the part when we take out those x bits. So there's an x part here and an x here. So it's 2 groups of x. So hopefully you can see that the length must be 12 minus 2 groups of x. And then the width is a similar thing. The total length here is 10, but then the width is, you're taking away this part here, x, and then this part here, x. So the width is similar. It's 10 minus 2x. Okay, so that's part A done because it says express L and W in terms of x. So we've done that. Part B says write down the rule for the volume. So the volume, hopefully, for a box is length times width times height. So I'm going to take 12 minus 2x multiplied by 10 minus 2x and then multiplied by x. And then that is an expression for your volume. And that should make sense that it's cubic because you're multiplying 3 groups of x together. You got an x here, an x here, and an x here. So then what you can do is you can go and graph it. So if we go over here and we graph it, and then maybe zoom out a bit, it's going to be quite narrow. So when you graph it on your CAS or on Desmos, you might need to change the axes. Let's go from 0 to 20. That looks a little bit better. Okay, there's only certain parts of this graph where this makes any sense. Firstly, you can't have negative. So let's be clear. First of all, we've got x on the x-axis. We've got volume on the y-axis. And you can't have negative x. So all this part here is not relevant. And then you can see here that the volume is going off to infinity. So the only part that we're actually interested in is between 0. Let me just show you here. And that first x-intercept, which is at 5. Okay, so that's really the only part that we're interested in. And, further analysis shows that if we look at this point, when you cut out a length, so when you cut out an x value of 1.811, you get the volume of the box to be 96.771, which is the maximum volume of the box that you can get. So yeah, hopefully that clarifies things. It should make sense that x can only be a maximum of 5, because if we go back to the question, this length here is 10. So if you were to cut 5 out from both sides of this width of this side of the box, you'd be cutting out the whole box and you wouldn't have a box anymore. So the maximum value that x can be is 5. Yeah, we also probably say we couldn't include 5 because if it is 5, the volume of the box will go to 0 and you can't have a box with 0 volume. So yeah, hopefully that clarifies things. Good luck with the studies.